And welcome to another episode of 3-Minute Videos with Nathaniel. Today, we will now solve question 1b of MAT Oxford 2018. Suppose there is a function. Find the values of k in which this equation is satisfied. This might look like a formidable equation, but this is actually what I normally do when I solve second-order differential equations. Second order involves d squared y over dx squared as the highest order derivative, and the order is how many times you differentiate it. We can extend this up to third order, third derivative, fourth order, fourth derivative, fifth order, fifth derivative, and so on until it gets a dizzying height like 1,578th derivative is the 1,578th order. Now enough of this, let's move on. What are the derivatives of e to the power of kx? This is a very common substitution when we're dealing with second order differential equations. dy over dx equals to k times e to the power of kx. Hey, bingo! It has the exact same term, only we have the constant. Now d squared y over dx squared equals, wait for it, k squared ekx. If you want to prove that dny over dxn equals to kn ekx, go for it. You could use a proof by induction if you want, but we'll not go through that here, as I think you can all do this investigation on your own if you learn about proof by induction. Let's substitute these values. K squared ekx plus k ekx minus ekx equals to ke2kx. Because the ekx is squared, that means that's why there's a little 2 here. And you might realize you could take away a common factor k, so this becomes this becomes this. These two brackets are always identical except for their signs. We will use an identity called the difference of squares identity. X squared minus y squared equals to x plus y, x minus y. This is another one of these common algebraic identities, so remember them. This equation becomes k squared e2kx minus e2kx equals to k e2kx. Now every term has this term, so we'll cross this out. And keep in mind that minus this just becomes 1. Now we write the now equation here, k squared minus 1 equals to k. Since this is a common factor, we can write k squared minus 2 equals to 0. What do we do? This is a cubic equation, so let's factorize it. Now in order for this to be 0, one of the brackets has to equal 0, and then bingo. K equals to 0, which is one solution, or k squared minus 2 equals to 0. K squared equals to 2, and k equals to root 2, or minus the square root of 2. So there are 3 solutions, which is option D. This might look like a formidable equation to you calculus beginners, but this is actually a very common substitution, and you will see it later in your studies of differential equations and advanced calculus. Thank you! Bye!